Hello, my name is Jody Hooks. I'm the Public Works Manager over Water and Wastewater, and we're here today to give you a brief tour of the city's newly constructed Southwest Water Reclamation Facility. This facility was constructed to provide wastewater treatment for the city's western service area west of I-45, and ultimately replaces the city's countryside wastewater treatment plant that is over 30 years old and suffers from regulatory compliance issues related to the growth spurt we encountered from 2000 to current. Funds were approved and construction began in November, December of 2010. The progress was tremendous over a 24-month period. We're now approximately 6 months ahead of schedule with the anticipated online date of sometime in mid-November. Okay, I'd like to take a minute to show you the operations training center for the new plant. The purpose of this building is obviously to provide an area for the operations crews to maintain and operate the plant. In addition, we wanted to provide a training facility where we could host state-recognized training in the water and wastewater field, and also provide a West Side Service Center ultimately for water and wastewater utilities. The training room was an important feature. We needed adequate space, proper training facilities to provide the state training, and provide an area for training for other city functions. Other departments certainly can use the facility also. Another function of this building is we have a process control laboratory, very important in wastewater treatment. It allows us to do all the process control sampling and tests that we need to operate the plant. Okay, while we're at a wastewater treatment plant, I'd like to take the time to briefly describe the wastewater treatment process. The majority of wastewater treatment in our country today is the activated sludge process. It's a process that's been around since 1913, or almost 100 years. The process itself has not changed. The technology to perform the process has changed tremendously. But in general, the wastewater treatment plant consists of collecting the wastewater, conveying it to the treatment facility, containing it, and then accelerating good old nature's natural stream assimilation. The activated sludge process is successful in accelerating nature, basically. I'd like to show you just what this plant does in 4 different containers. The first container is raw influent wastewater. It's what's collected through the pipes from your households, businesses, and everything that's conveyed ultimately to the plant. It arrives in what we call a very unstable form. You can see it's cloudy, it does not settle, it's full of pollutants and organics. The next step in the process is to take it to a secondary level of treatment. This level of treatment actually stabilizes it, removes organics and pollutants. I'm going to show you what a stabilized wastewater looks like after the secondary process. This is a stabilized form. When it's put into in a settled environment, it allows it to settle. As you'll see, a very thick solid on the bottom and a very clear liquid end product on the top. This end product is the final effluent. As you can see, as it leaves the plant, it's disinfected, filtered to a high degree, and becomes a very high-level, pollutant-free, environmentally friendly product. That's wastewater treatment in a nutshell. This is the operations control room. This is where the operators have a good view of the plant itself, and they have SCADA systems or computer screens that can monitor all the operations aspects of the plant, make a substantial amount of changes from here, do other data collecting and analyzing type activities. All right, we're going to start with some wastewater 101. Wastewater treatment in general is broken up into different processes, so to speak. One of the first stages of treatment is pre-treatment. That starts with us monitoring all the businesses, commercial business, retail businesses, anything that can potentially discharge something harmful to the collection system. That begins pre-treatment. Once we collect it, convey it to the treatment plant, then begins the preliminary treatment process where we screen out all of the plastics, paper, everything that's harmful to pumps and takes up valuable volume capacity space. That's screened and that's taken to the landfill. The secondary process is the most important part of the treatment process. This is the part where the microorganisms do the work of removing and reducing organics and pollutants. It's a natural process, it's a biological process, and again, the microorganisms do the majority of the work. Our job is to provide the optimum environment for them to be healthy and to do their work in the most efficient manner. As we go through the plant, I'll show you the area and the things involved in maintaining that portion of the process. The next portion of the secondary treatment process is secondary clarification. That's where the physical part of the treatment system comes in. The next portion of the secondary treatment process is clarification. We'll visit a secondary clarifier, and that's an area where the product is put in a very quiet environment and allowed to settle. This is the area where the physical treatment takes place, where the microorganisms settle, creating a sludge or liquid solids on the bottom of the tank, and the clear effluent or the treated product is discharged from the tank and on to the disinfection process. In between the secondary process and disinfection is a tertiary filtration that is built into this plant. That is really a final polishing effort to get our effluent standards to a type 1 reclaimed or reuse water level. We're now located at the front end of the process in what we call the headworks. It's the highest structure in the process because we rely on the cheapest form of energy, gravity, to get the hydraulic flow through the plant. So this is the beginning of the process. This is the preliminary treatment process. This is where we screen sand, grit, paper, plastics, anything that we don't want in the plant that could be harmful to pumps and take up valuable volume space. This is what we call a step screen or bar screen. Below there is a concrete channel where the flow comes through and where all the screenings are captured, washed, and then put into a roll-off and ultimately taken and disposed of at a landfill. This is a grit settling chamber, another very important part of the process. Removing grit, sand really extends the life of pumps and everything downstream of this particular structure. This too is ultimately disposed of at a landfill. The building we're looking at is the dewatering building, or the solids removal. Very important part of the treatment process, a very costly part of the treatment process. It's where we remove dry solids for ultimate disposal at landfill. The solids removal unit is one of the most costly aspects of a wastewater operation. There was some focus on workforce efficiencies in this area and also disposal costs. We're now in the aeration basin. This is really the most critical, important part of the process. The aeration basin is where the microorganisms that reduce organics and pollutants do all the work. Our job is to keep them in an optimum environment where they work in an efficient manner and remove as many organics and pollutants as they can. The key component of a healthy microorganism is dissolved oxygen. These aeration basins provide an environment with adequate dissolved oxygen, food, everything it takes for the microorganisms to do their job in an efficient manner. Included in this project was one of the most efficient aeration systems available today. It starts with what you see, fine diffusion. It's a very efficient way for air transfer within the basin itself, and from there it goes to the blower itself. It's a blower technology that allows a broad turn down range to meet the oxygen demand. That right there creates an energy savings of 30 to 40% of your aeration cost. We're now located in the blower building where all the aeration control takes place. Again, energy efficiency was a key point in this construction project. The blower system we have allows a broad turn down range to match the dissolved oxygen load. That creates a great electrical savings, 30 to 40% of the aeration load within a wastewater treatment process. The aeration portion of energy usage in wastewater treatment is 70% of the overall electrical load. So you can see where this area right here is a major money saver in regards to energy. Okay, we're now at the final portion of the secondary treatment process. We're on what we call a secondary clarifier. Secondary clarification is represented well in the second jar of our description of wastewater treatment in the lab. You'll see where the clear liquid is on top. That's what overflows into the effluent structure of this clarifier, and then the dark settled sludge on the bottom of the jar is what's at the bottom of this tank, and ultimately either return to the aeration flow or discharge to the solid removal. The wastewater is now stabilized. It now takes on the physical portion of the treatment. The stabilized solids begin to settle to the bottom. As they settle, they collect pollutants, organics, and take it to the underflow of this tank, the clarifier, and that is either removed in the solids removal portion of the treatment process or goes back to the aeration process. The overflow or the effluent of this process is the clear liquid or the final jar that we seen in our description of the wastewater treatment process. From there, it's really reached its final treatment point other than filtration and disinfection. So this is a very critical portion of the process. All right, we're at the next step of the treatment process. We're at the tertiary disc filters. This is where we filter the effluent from the secondary clarifiers and take it on to the disinfection level. Disc filtration was an important technology for us because the city has chose to kind of move in the next level of reclaimed water. This allows us the ability to deliver type 1 reclaimed water. That's the most stringent reclaimed water in the state of Texas. This filter unit filters water from the inside out and ultimately discharges to the next step, which is the disinfection portion. We're now at the final part of the wastewater treatment process, disinfection. In this facility, we chose ultraviolet disinfection over the typical chlorine application, basically for safety reasons. Ultraviolet disinfection technology has improved tremendously over the last few years, and it's just a safer, more environmental friendly way to disinfect. We now take it to what we call a relift pump station. We pump the wastewater north to an unnamed ditch that ultimately leads to Clear Creek. All right, I'd like to thank you for the short visit and tour of our facility. For a further in-depth understanding of the wastewater treatment process, we encourage and welcome tours. We often do tours for schools, Boy Scout troops, and parents in general. It's a good way to see what happens and how we keep the local environment safe, and just kind of the complexities of wastewater treatment in general.